Today we are going to make a citrus battery. First, let's learn a little bit about how batteries work. A simple battery is made of two different types of metals, called electrodes, separated by a conductive solution called electrolyte. Our two electrodes are called the cathode, which faces the positive terminal or end of the battery, and the anode, which faces the negative end or negative terminal of our battery. Remember that our cathode and anode are separated by a substance called electrolyte. You may have also heard electrolyte referred to as battery acid. Finally, most batteries have some sort of conductor, which helps conduct the electricity generated inside the battery to the terminals. Now that we know a little bit about what's inside a battery, let's learn a little bit more about how they work to generate electricity. A battery generates electricity through a chemical reaction called a redox reaction. Redox stands for reduction, oxidation. Reduction means that the substance is losing electrons, while oxidation means that the substance is gaining electrons. In our battery, the cathode loses electrons as it interacts with the electrolyte, while the anode gains electrons as it reacts with the electrolyte. As the cathode loses negatively charged electrons through reduction, it becomes more positive, while the anode becomes more negative as it gains electrons through oxidation. Remember that our cathode and anode are separated from one another. This means that if we want the electrons to flow, we need to give them a pathway to do so. We can create a pathway for electrons to flow by connecting a wire between the positive and negative terminals of our battery. With a pathway for movement, our negatively charged electrons are now free to flow along the wire towards the positive end of our battery. This movement of electrons is an electrical current. We can harness the power of these moving electrons to power things like light bulbs and our devices. Now that you know a little bit more about how batteries work, you may be wondering how we're going to build one out of a piece of fruit. It turns out that our lemon or piece of citrus will be providing the electrolyte solution. Our two electrodes will be made from a copper penny in the case of the cathode and aluminum foil in the case of the anode. These will be stuck into slits cut into our piece of citrus so that they can interact with the electrolyte solution. We'll also add some aluminum foil to our copper penny to act as a conductor. As the aluminum foil and the copper penny interact with the lemon juice, the cathode will become more positive as it loses electrons, and the anode will become more negative as it gains electrons. As soon as we touch the two strips of aluminum foil, electrons are free to move from the negatively charged anode to the positively charged cathode, creating an electrical current. While our citrus battery is not as powerful as a typical double or AAA battery, in some cases they can even power a small LED. Let's try it out ourselves and make our own citrus battery. To make a citrus battery, you'll need a piece of citrus fruit. Lemon, orange, or grapefruit work well. You'll also need a knife, some aluminum foil, a penny, plastic-coated paper clips, a ruler, scissors, writing utensil, and some soap and water. I had some clementines on hand, so that's what I'll be using to make my citrus battery today. We want the copper in our penny to react with the clementine juice, so it's important to make sure that we've scrubbed all the dirt and grime off of our pennies before starting. Next, we'll need to measure and cut some strips of aluminum foil. You'll need at least 2 strips of foil, each 20 centimeters long by 3 centimeters wide. I'm going to measure and cut 3 strips, so I'll have 1 extra. Once your aluminum foil has been cut, we'll want to fold it so it's not quite so flimsy. Fold each strip of foil into thirds lengthwise so that you have a strip that is 20 centimeters long by 1 centimeter wide. Next, we'll need to cut 2 slits in our piece of fruit for our cathode and our anode. Make sure that you've cut deep enough to cut completely through the peel. Use caution when using a knife or get a parent or guardian to help. Place your penny in one of the slits so about half of the penny is sticking up above the peel. Next, you'll want to take one of your strips of foil and place it in the other slit. Next, take another strip of foil and use a plastic-coated paper clip to paper clip it to the penny. You'll want to make sure that the foil has good contact with the penny, so you may need to fold up the foil a few times to make sure that it does so. If you don't have plastic-coated paper clips, you can use a piece of tape. Just make sure that your penny is dry so that the tape will stick. Now that we've made a citrus battery, it's time to test it out. As you bring your two strips of foil together, you're creating a pathway for electrons to flow, called an electrical current. Depending on your battery, you may be able to feel a small electric charge as you connect the two strips of foil. To prove to ourselves that electricity is actually being generated by our piece of citrus, we can use a device called a multimeter. With our multimeter, we can measure the difference in charge between the cathode and anode in our battery. This difference in charge is called voltage. If we are able to measure a voltage between the two ends of our battery, we know that our redox reaction is occurring and electricity is being generated. When I connect the two leads of my multimeter to my cathode and anode, I see that the voltage reads approximately 0.4 volts. For reference, a standard AA battery produces about 1.5 volts. We can increase the voltage of our battery by adding additional cells or cathode-anode pairs. Here, I've placed an additional copper penny and strip of foil in series or next to my first pair. Adding an additional cell increases the voltage slightly, which now reads approximately 0.6 volts. As you're connecting your cells in series, make sure that you're doing so as shown here. You'll want to connect your cathode from your first pair to the anode of your second pair. Then, add a penny with another strip of foil to create your final cathode. You can string together multiple cells this way to increase the voltage of your battery. If we increase the total number of cathode-anode pairs to 4, we now see that the measured voltage is approximately 1 volt. You may be able to sense a slight electrical current when you connect the two strips of aluminum foil in your citrus battery. If you can't, try increasing the voltage of your battery by increasing the number of cathode-anode pairs or cells. Feel free to experiment with different types of citrus fruit if you have it, and see what you can create.